Before moving on to the next topic, you need to just do your exercise 2.1. In exercise 2.1, you have questions similar to some graph. Graph represents the polynomial. In that, you need to find the number of zeros, right? In that, the number of times the graph touches the x-axis gives a number of zeros. That's it. That's why I'm going to skip that exercise and moving on to the next important part, that is a topic which is about the relationship between the zeros and coefficients of a quadratic polynomial. So let us have a quadratic polynomial, say ax square plus bx plus c. This is a quadratic polynomial and let me name this as p of x. Okay, this is a quadratic polynomial. You have the coefficients a, b and c here. You need to find the relationship between this and the zeros. Okay, but in the previous one, that is the last year, you have learnt about factor theorem, right? So from factor theorem, you can understand that if alpha and beta, let me take this is alpha and this is beta, they are the zeros of this polynomial. Then by factor theorem, x minus alpha is a factor of p of x and x minus beta is also a factor of p of x. Because this is a only square term, that is quadratic only, you can just multiply this and multiply this by a constant to equate it to this p of x. Therefore, p of x can be written in this format also. Or I can write it as ax square plus bx plus c is equal to, let me take k and just going on multiplying this, okay, you get x square minus of alpha plus beta x plus alpha beta. I think you know the expansion of x minus a into x minus b comes to be x square minus a plus b into x plus ab. That's how I am applying here and just getting these values. So I'll take k inside. This becomes kx square minus k into alpha plus beta x plus k alpha beta. Okay, now we have x square term at both the sides with a and k. So just by seeing, I can just say that the x square terms, the coefficients are going to be equal. Coefficients are going to be equal. Let us a is equal to k. Okay. This point is also very important to be remembered, that you can just write it as in this format, or you can write p of x in this format. This is one point to be remembered, because if you are given the two roots alpha and beta to be some numbers, say 1 and 0, I can just substitute the values of 1 and 0 in this case and get a quadratic equation which have these two zeros. That is a direct one. So now we are going to find the relationship between them. So that comes to be a is equal to k, directly we got it. Now we are going to equate the x terms, that is b is equal to minus k into alpha plus beta. So now alpha plus beta becomes how much? Minus, I'll bring it this side, k also comes to the denominator, so this becomes minus v by k. K is equal to a, so I can substitute it to be minus b by a. Alpha plus beta is equal to minus b by a. This is first relation, that is between the zeros, that is alpha and beta are the zeros, right? And these two are the coefficients of x and x square and all. Okay, now you have the constant term left out, that is c is equal to k alpha beta. K alpha beta. Bringing this k this side, you can get alpha beta is equal to c by k. From here you found out that k is equal to a, right? So this comes to be c by a. Alpha beta is equal to c by a. This is the second equation, or the relation that is between the zeros and the coefficients of the quadratic polynomial. So just this is an important point, and here also this is one important part. These two things you need to just remember. So there can be different types of questions, like you can be asked about maybe you are given the two zeros, as I have already told, and you are asked to find the equation of the polynomial having those two roots. Or you can be asked to find the roots by a given polynomial. Say I can tell x square minus 2x plus 1, you are given this, and you are asked to prove this relation by finding the zeros first and then applying this, you have to just show that alpha plus beta is equal to minus b by a. Okay, let us have an example of how to have this question. So we will take some polynomial q of x, not always p of x, right? Q of x. Let it be q of x. Maybe x square plus 7x plus 10. We name it as q of x. Okay. In this question, you are asked to verify this relation. Verify this relation between the zeros and the coefficients of the quadratic polynomial, that is x square plus 7x plus 10. So how do you need to find the zeros of the quadratic polynomial? So last year we have also learned about how to make the factors and all, that is x square plus 7x plus 10. You are going to equate it to 0 and get the factors and just find the zeros of those polynomials. So I need to split the middle term now. That comes to be x square plus 2x plus 5x plus 10 is equal to 0. The mechanism to split this is just like this. This one should be the sum. We know that alpha plus beta is equal to b. Considering a is 0, a is 1, right? So it comes to be 1 only, minus b. Okay, then alpha beta is given here, that is 10, and this is 1 itself, right? So alpha beta is equal to c, or it is equal to 10. In this case it comes to be minus, let it be 7 only. Okay, so we need to find two numbers such that their sum is 7 and their product is 10. So by prime factorization, 10 can be written as 2 into 5, right? Because the sum is 7, both needs to be positive, that is plus 2 and plus 5. Sum gives 7 and their product gives 10. So because of that I have divided this 7x into 2x and 5x. Okay, so now the thing to just take the important factors outside. So here x is common, right? So it comes to be x into x plus 2. Here 5 is common, so plus 5 into x plus 2, that is equal to 0. That is x plus 2 is common out of these two terms. Now you have x here and 5 there. Okay, one easy mechanism to just see this, you have the coefficient of x square to be 1, then the number that you have got here, directly you can write it as x plus 2 into x plus 5. That's how you have observed here, right? That's what. So now you need to find the zeros here. So that comes to be, both should be equal to 0, that is x plus 2 is equal to 0 and x plus 5 is equal to 0. X is equal to minus 2 and this becomes minus 5. Minus 2 and minus 5. This is the zeros. So this is alpha and this is beta. I'm just taking that. So next part is to verify that part. For that we need alpha plus beta. Alpha plus beta is minus 2 minus 5. Minus 2 minus 5, that is minus 7. Minus b by a is, this is b, right? A is 1, so this comes to be minus 7 divided by 1, or minus 7. Okay, next you have alpha beta, that is minus 2 into minus 5, that is 10. And also have c by a. C by a is 10 divided by 1. 10 divided by 1, that is 10 itself. From these two you can show that alpha plus beta is equal to minus b by a and alpha beta is equal to c by a. These two are the relations that you have to verify. Here you found out that both are equal, right? That's enough. You have to just write that statement at the last, that is verified. Okay. Next type of question that comes is to find the quadratic polynomial when the zeros are given. When the zeros are given, these type of questions are there in the exercise. So I'm just going to do one after that. It is given that sum and product of the zeros, sum and product of its zeros is root 2 and 1 by 3 respectively. 1 by 3 respectively. Find the quadratic polynomial. Okay, you are given sum that is root 2 and product to be 1 by 3. You are asked to find the quadratic polynomial. Okay, you had a form that is x square minus alpha plus beta into x plus alpha beta, that is p of x. I had showed you, right? This form we are going to use here. Here this is the sum, right? So this in place of the sum I should write. Yes, and you have the product to be 1 by 3. This is the product, right? Here I am going to write the product. So now the polynomial is, before writing you need to just write this general formula, and you need to write this to be alpha plus beta, and this is alpha beta, right? That you need to write, and then go on writing the polynomial is x square minus root 2 x plus 1 by 3. This is the required quadratic polynomial. Okay, next one is about cubic polynomial. Relationship between the zeros and the coefficients of a cubic polynomial. Generally this is not so important for the examination point of view, not for the board exam, just for your knowledge. This is the cubic polynomial. This is let me have some p of x to be ax cube plus bx square plus cx plus d. So by factor theorem, if you have alpha, beta, gamma to be the zeros, then x minus alpha, x minus beta and x minus gamma to be the factors of that, and multiplied with some constant, you get the p of x. Okay, so you are going to multiply now. This comes to be, leave this x minus alpha, let it be first. I am going to multiply the remaining things. That comes to be x square minus beta plus gamma x plus alpha beta, beta gamma, right? Beta gamma. Okay, now I need to multiply this again. That comes to be, you need to have a bigger bracket. That comes x cube minus alpha plus beta plus gamma x plus alpha x square. This alpha beta plus beta gamma plus gamma alpha x plus alpha beta gamma. I am just skipping so many steps here. You need to get this as a last step over there. So you need to just write, go on doing. At last you are going to get this. So similar to the previous one, you are going to equate it to ax cube plus bx square plus cx plus d. So a is equal to k. You need to take k inside. So I'll write k everywhere inside. I'll remove this and write it here. K, k and k. Okay, this is minus, right? Yeah, you'll get minus here because you have plus, here you have minus, so you are going to get a minus sign over there. Minus k alpha beta gamma. So you have a is equal to k, b is equal to minus k into alpha plus beta plus gamma. Therefore alpha plus beta plus gamma comes to be minus b by k is 1a. So this is minus b by a. Okay, alpha plus beta plus gamma is equal to minus b by a. So now you have your next one, that is k into alpha beta plus beta gamma plus gamma alpha. This is just a cyclical. First, second, second, third, first. Like that. Ulta pulta. You have k into that thing, and that is equal to c. That is the x term. So what does this relation comes to be? Alpha beta plus beta gamma plus gamma alpha is equal to c by a. Because k is equal to a, I am going to bring this down, so you get this one. This has the relation. So also d is equal to minus k alpha beta gamma. So now you have alpha beta gamma is equal to d by minus d by k is a. I'm bringing this minus sign first here, and then I'm going to bring the k down. So k is equal to a, right? So I'm going to write it as minus d by a. These three are the relations that are going to be connected between the zeros and the coefficients of the cubic polynomial. Okay, this is a simple one. You have some extra questions that is given in the optional exercise. If you want, you can try based on this, and also you have an example question also. Okay, moving on to the exercise. Okay, I have written a question just based on that cubic polynomial, that's relation between the zeros and the coefficients. This is a simple question, that's why I'm opted from the optional exercise. So the question is, if the zeros of the polynomial x cube minus 3x square minus plus x plus 1 are a minus b, a plus b and a, you are asked to find a and b. Okay, so I found that alpha is equal to a minus b, beta is equal to a plus b, and you have your gamma to be a. Okay, from the first relation you have that the sum of the three should be equal to the coefficient of this divided by the coefficient of this. Okay, so you have alpha plus beta plus gamma to be minus b by a. I am not referring to the b and a here, I am referring to this b and this a. So this comes to be minus of minus 3 divided by 1, that is 3. Okay, what is alpha plus beta plus gamma? Alpha plus beta gamma, I should add this, that is a minus b plus a plus b plus a. So this I am going to cancel here, that comes to be 3a, 3a, but alpha plus beta plus gamma is equal to 3, right? Therefore a is equal to 1. Now I got a is equal to 1. Now I need to find b. So I need to take some other relation. We have the sum here now. So let me take product. Product will be easier, I think, instead of taking that cyclical terms and all. So let me take alpha beta gamma. Alpha beta gamma is a minus b into a plus b into a into a plus b into a minus b, a minus b. Let me substitute a is equal to 1. So this is 1, leave this. So you have 1 plus b and 1 minus b, that is 1 minus b square. That is alpha beta gamma. What is minus d by a? Minus d by a in terms of this, not the required a. So now what is minus d by a is minus 1. So 1 minus b square comes to be minus 1. 1 minus b square is equal to minus 1. Taking minus 1 this side, 2 is equal to b square. B is equal to plus or minus root 2. Okay, so therefore a is equal to 1 and b is equal to plus or minus root 2 are the solutions. They are the solutions for the given polynomial. Okay, I'm going to start with exercise 2.2. The first question is about you need to find the zeros of the polynomial and you need to verify the relationship between the zeros and the coefficients of the polynomial. So the first question is x square minus 2x minus 8. For finding the zeros, you need to equate it to 0. So for splitting the middle term, so this looks like 2. So this is, the product is negative. Product is minus 8 and the sum is minus 2. So 8 comes to be 4 into 2. Okay, 4 and 2. But here is a negative sign. So 4 should be negative and 2 should be positive. So this comes to be, as I have took the shortcut method, just directly I can write it as x minus 4 into x plus 2 is equal to 0, or x is equal to 4 comma minus 2. These two are the zeros. These are the zeros. So I need to find alpha plus beta. Alpha plus beta is 4 minus 2, that is equal to minus 2, minus b by a is equal to minus of minus 2 divided by 1, that is minus 2 plus 2 itself. Okay, now you have alpha beta. Alpha beta is equal to 4 into minus 2, that is minus 8. Then what is c by a? C by a is always here also minus 8. So you just found out that the relation was correct. So we are going to do the next question here. Okay, Here we are going to do the next question. This you have to equate it to 0. This looks like a square minus 2ab plus b square term. Okay, for that where a is equal to 2s and b is equal to 1, 2s minus 1 whole square. This comes to be 2s minus 1 whole square is equal to 0. Therefore, both are the same terms, right? Both turn up to be the same terms. That's why I have to just write it as 2s minus 1 is equal to 0. S is equal to 1 by 2. Therefore, both the zeros come to be 1 by 2 itself, because it's the square, right? So 2s minus 1 is equal to 0 and 2s minus 1 is equal to 0. So you are going to get 2 zeros out of that itself. So you want alpha plus beta. Alpha plus beta is half plus half, that is 1 by 4. So what is minus b by a? Minus b by a is minus 4 divided by 4. Okay, that comes to be minus 1. Okay, alpha beta is equal to, okay, sorry, you have 1 by 2 and 1 by 2, right? So this minus of minus, this comes to be plus 1. Here you have half plus half, that is 1. So this both come to be equal, right? So while doing itself, you can make out that there is going to be some mistake, right? Alpha beta is how much? Half into half. Half into half is 1 by 4. C by A is 1 divided by 4. So both are equal? No problem. Going to the next question. 6x squared minus 7x minus 3. This looks like so irritating one. So need to get a middle term now. The product should be the, you have the sum and the product, right? For splitting the middle term, the sum is minus 7 here, and the product should be the product of these two terms. Here always we had 1 here, that's why we just neglected that. So here you have 1 6, so you are not going to neglect this. This becomes 6 into minus 3, that's his product is minus 18. So need to find two numbers whose difference is 7 and the product comes to be 18, that is 9 and 2, right? 9 and 2, which should be positive here. 2 should be positive and this should be negative, so that the sum comes to be minus 7. So I need to split this middle term in the format 6x squared minus 9x plus 2x minus 3 is equal to 0. So here I need to take 3x common outside, that comes to be 3x into 2x minus 3 plus 1 into 2x minus 3, that is equal to 0. So now you have 3x plus 1 that you are going to take, and 2x minus 3 is however common. So you have to get two zeros here, that is 3x plus 1 is equal to 0. Let me wrap this fourth question. 3x plus 1 is equal to 0 and 2x minus 3 is equal to 0. 3x is equal to 1, no, minus 1, x is equal to minus 1 by 3. You have then 2x is equal to 3, x is equal to 3 by 2. Okay, you have got two numbers now. These two are the zeros. These two are the zeros you are going to get. Now you need to find alpha plus beta, that is minus 1 by 3 plus 3 by 2. What is going to be? While taking the LCM, we get 6 here. So this minus 2 into minus 1, that is minus 2. 3 into 3 is 9 plus 9. So it becomes to be 7 by 6. Okay, what is minus b by a? Minus b by a is minus of minus 7 divided by 6, that is 7 by 6. You are getting 7 by 6, here also 7 by 6, no problem. Now we have alpha beta. Alpha beta is minus 1 by 3 into 3 by 2. 3 and 3 is going to be cancelled. You get minus 1 by 2. So what is this? This will be c by a. C by a is minus 3 divided by 6. Minus 3 divided by 6, that is minus half. Both are going to be the same. So we already verified. You're just going to write that the verified. This is verified. So the last question I am going to do here is the fourth one. Fourth one is the fourth one is 4u square. They have used a different variable. 4u square plus 8u. So this is a different type of question. How to find out the factors is more important than just going on doing this methodically here. Now you have 4u square plus 8u is equal to 0, that's equal to 0. So now you have 4u common out of this. You get 4, if you have 4u and u plus 2 here. Therefore, either 4u is equal to 0 or u plus 2 is equal to 0. That is, u is equal to 0 or u is equal to minus 2 come to be the zeros of these two. And just go on doing this again. Okay. Next, moving on to the second question. Moving on to the second question of the exercise. The second question is very simple. Out of that, I'm just going to write that. Okay, now we have the second question of the exercise. Here I have written only few of them. The second part of this already I have explained in one of them. So now you have, this should be the sum and this is the product as given in the question. The first one is the sum and the product. You are asked to find the quadratic polynomial. That is, alpha plus beta is equal to 1 by 4 and alpha beta is equal to minus 1. So if you find p of x, it should be x square minus alpha plus beta into x plus alpha beta. This is the only thing that is required in this question, this whole part. So you are just going to substitute. That comes to be x square minus, the sum is 1 by 4, right? So 1 by 4 into x plus product is minus 1. So this is minus 1. I can write it as x square minus 1 by 4x minus 1 is the required polynomial. So now you have the sum to be 0, alpha plus beta is 0 and alpha beta is equal to root 5. So how it should be? That comes to be x square minus 0 into x plus root 5. That is, x square plus root 5 is equal to 0. Not equal to 0, just x square plus root 5 is a required quadratic polynomial. Now we have the fifth part, that is sum is minus 1 by 4 and product is 1 by 4. So just going on substituting that, x square minus of minus 1 by 4x plus 1 by 4, that comes to be x square plus 1 by 4x plus 1 by 4. That is the only thing that we're going to get here. Similarly, you are going to get x square, here alpha plus beta is 4 and alpha beta is 1, right? So this comes to x square minus sum is 4 into x plus 1, that is x square minus 4x plus 1 is the required thing. Next, we'll move on to the next topic in the next class. Thank you.